Alright, today we have a new project, which is right there, but first I'm going to get a drink. Sorry, it's not fancy, but I have no alcohol. I'm 19. I don't drink alcohol. This is a toast. Thank you all for 200 subscribers. I hope you enjoy my content for years to come, and I hope I keep making videos for years to come. Cheers to you. Alright, for today's video, move this here. We have an old oscillating fan from probably the 50s. Solid metal. Not sure if I can get this one working. This isn't a good sign already. Either somebody tried to rewire it and failed miserably, but that's not normal. It is an oscillating fan, as you can see. It's made by GE. This is one of the GE's lower end disposable fans, which was supposed to be disposable. I bet if I put a cord on this thing and hit that power button, I bet it's gonna go run. I bet it's gonna run when I put a power cord on it. It is a 2-speed oscillating fan. This is the switch. But it needs a new cord. So, without further ado, let's begin. Let me get my screwdriver. Alright, got my 2 screwdrivers that we're going to need. It's so old it requires flathead screwdrivers, and I got a nice set right here. Wooden handled tools, I love them. Take this apart, you got flathead screws right here. And right there, you got 4 sets of them, and you have to get it aligned with the blade to get them out. Oof, this fan's never been taken apart, I guess. It just snapped. Also, this is what makes it a cheaper fan. This has the blade is mounted with a rubber piece that grips onto the shaft held by friction. So what you need to do is you need to get that off, which you just grab a hold of the back of the blade. Back of the blade like this, and you pull on it, and it's like you would hope. Okay. Sometimes you just have to call for drastic measures, and this would be one of them. Really? Well, that works. I'm just about getting that damn off. Oh, there's one thing done. Yep, and there we go. Well, hey, I'll take that. Hell yeah. Nice and simple. Almost simple. Guess I don't have to take that off, which means I can just slide the blade back on it. I really don't know why this thing just wouldn't pop up. Oh, okay. Alright. And that's friction fitted for you. What the fuck was somebody thinking? Oh god, this is going to be interesting. I really hope this coiling burned out. Oh wait, there should be some screws in here. I'm not seeing them. This thing just yanked out. This is plastic. Either it's aluminum. No, it's plastic. I think. Oh, no, that comes off. Ew. Jesus Christ. What was somebody thinking? I don't know if someone was trying to wire this for... Okay, that... That's one coil. This is the other coil, which... Somebody's thinking this is just bad. This is bad. This grease is actually freaking hardened. I can't put this fan. I gotta take this whole thing apart. This thing needs proper maintenance. So it shouldn't be too hard to do. Just take out a few screws. No, like 2 screws, and the coil should come out. No fingers crossed. Don't. That. I'm sure that's okay. Oh, I can get this fan all apart. It's too hard. Alright, let's just let me take out this, which, by the way, is not original. When I found this fan, it did not have a nut on it. It had nothing. Okay, here's the old grease inside of it. Say it's not very good anymore. Not really. So I'm gonna have to get the old grease out. Alright, here we go. Hey, look at that. It likes the new grease. As it runs, it gets more quieter, but it does need oil. Oh, would you look at that? I just need to find a knob that will go into it. Alright, today I have this 1950s General Electric Telecron clock. It is a model 2W106, 116 volts, 60 cycles, and 2 watts of power. General Electric Company, Ashland, Mass, made in USA. These were a very nice clock in the 50s. And this is a friend's clock. It was his grandmother's, and he wants me to restore it for him, as you can see. It's pretty freaking filthy. Pretty filthy, if you ask me. Who knows when the last time this clock ran? The cord is rock hard. And, well, it basically takes its shape. That's a rock hard cord. And the wire has had some weird chemical reaction. So, I'm going to get a new cord on this clock. It's a nice Telecron clock. And I'm going to get this one working. And we'll find out if the mechanism even works on it. It may. These old Telecron clocks are still top of the line. Not that quartz bullshit, but let me get this one open. I'm now going to open it up. Just 2 simple screws. Okay, here we go. Ooh. This thing might have been in a house fire. Looks like soot to me. Oh, it's all in there. But this is what's in an old 1950s electric clock. Telecron clock motor. That was cutting edge at the time. These were around, I believe, in the 1930s or 20s, maybe. But these are very common for These were a very common clock motor for clocks in the 50s. Highly reliable motor too. I bet this still works. Just needs a new cord, which, as you can see, won't be too hard. Just have to desolder these wires and put a new cord in. Let's see if the hand thing moves. Yep, still moves. Could use some oil though, but it does. Let's see if the time set knob still turns the hands. Oh yeah, it still moves. Could use some oil though. It's a little crunchy, but still moves. Gotta think this clock is probably 78 years old. Or older than that. It's probably 78 years old. But yeah, look at that. Whew. Well, let's desolder this old wire and get this old clock running again. Wouldn't that be nice to get an old clock running? First off, I'm going to start by snipping this old wire. I mean, look at that shit. Just by age, it's basically, it's hard. Unsafe. Here's the new cord we're going to replace it with. It's vintage, but it's still good. Nice and flexible. Nice clean looking, because I'm going to be cleaning the clock too. Once I get it powered up and verify it's fixed and it works. So, let's see. Get this off. Just snip that off. one. There's two. There we go. That's off. Okay, today we have a piece of Cold War history. It is a CDV-700, model number 6A, the Victorine Instrument Co. This is a Cold War era Geiger counter made by the Department of Civil Defense for civilians to use or their staff in case of a nuclear war. Let's open it. Alright, let's take a look in here. So, it also has an operational check source. But you also get a schematic with it, because in the Cold War, no more repair centers because they're probably all blown up or destroyed. So they gave you a schematic so you can fix it yourself if it goes bad. Here's the inside of it. I think this one dates to like the 60s, if I'm not mistaken. I don't remember. But yeah. There's your transformer, your high voltage rectifier. This is your Corotron tube, which that's going to be discussed in a minute of what we're going to be doing to that. And there's an old electrolytic right there. Overall, it probably would still work. Probably. And some transistors. Takes 4D batteries, so let's give it the juice. See if it even works. Okay. Let's give it the juice. Okay, so same polarity for each cell. Oh, a little finicky. Okay. Then you take these little clamps and you put them on. And there you go. It's got the juice. Let's see if it even works. Oh, it also came with the old pair of headphones. And, yeah, that's going to need some repair. Yeah, it's got let's take a look at the front here. So as we can see, here's the meter. It measures in millirontgens/hour or C/M, which I don't even remember what that means. This is the C/M scale, the bottom scale, and the millirontgens is the top scale. Here's your probe for measuring radiation. That's a tube. It's probably was somewhere damp at one point in time. Headphone port. It does have a little amplifier in it. -24 headphone port. Volt. Here's well, let's try it. X100 times 10 times 1. Let's see if it works. We got a little check source here. Let's see if it works. Holy shit, it does still work. Okay. Times 10. If it goes to 0.2 and stays, then it's still calibrated. This one's being a little stubborn though, it's kind of slow. And I can actually hear... Yeah, you can actually hear it, even though... Here, let me give you a little listen here. You can actually hear the ticking, even though there's no headphone port. That, I believe, is the, oh. It's coming from the headphone port. Ain't that something? Interesting how that works. But, oh, I think we got a sticky meter too. Yep, it's still calibrated just about. Well, it still works. Now, there's a problem with this. In its current state, it's great. It does work. Albeit, I think it's got a little bit of a sticky meter, but that's to be expected. There is that Corotron tube. I'll show you. Let me take out the juice. We'll get into that. Let's discharge it. I don't want to get shocked by the damn thing. It creates 9,000 volts to 1,000. Don't want to play with that. But, so this Corotron tube right here, it's a problem component. It can fail. And when it fails, it's very catastrophic to the equipment. So we need to fix that. So what I'm going to do is I'm going to take this all apart. I'm going to replace it. Being careful that I don't see where that capacitor is located. It's not that one. C400. Oh, here it is. It is C2 and it is 400 microfarad. And I guess the voltage is on the capacitor itself. So, yeah, I'm going to replace that one because, well, let me face it. It's probably no good, actually. It probably should be changed. Yeah. Don't know what any of this means. There's no documentation or anything about where to put that. I'm probably not even going to replace it. I think that part is plenty good. Let's see. Been a while since I've used this fucking thing. It's out. Oh, yep, it's out. Oh, I gotta get that shit off. Okay, I gotta get that damn thing cut. But look at it. It's an original Corotron. I'm keeping this though. This is pretty fucking cool. Yep, it's original Corotron. Be interesting to test to see how radioactive that is.